Right. Okay. So, tutorial. What do we need to see?
3 and 4.
3 and 4, yep. On
1 and 2.
same page?
Yeah.
I don't think I have time to do everything on one page because we have another page too, don't we? We have 2 pages. So let's see, we'll just do firstly, the first one, the 2 support. So I'm talking about the 2 support first. Yes, the 2 support. The 2 support. The first page, yes. First, we will start at the first. Then on to the second. So what do we need for the 2 support? Do we need anything? 3? You want 3? And what about for the second one?
3 and 4.
3 and 4.
Or 3 and 4 seem to be.
Okay, well I'll do 4 anyway. So 3 and 4, yes. Not taking right? You can't do 1 and 2 because I write what I did in class. And I don't have time to do all of them. I'll do 3 and 4 and I'll do, you said you want this one here, was it? Yeah?
Actually, it's like
This one? Yes, they're all similar. Okay, I'll borrow this, okay? I'll do 3 first. Okay. 3. So, okay. I'll draw what we have. So it looks like we have this. And then we have a force here of 15G. And then a force here of R. Then here 5G, and then here 3G, and then here 2G. And then this distance here is x. Then this distance here will be 3 minus x. And this distance here is 2. And then this distance here is 1. Each of those distances. Or if you prefer, you can say it like this. Here to here is x. Here to here is 3. Here to here is 5. And then to the very end is 6. So 6, 5, 3 and x. If you want to say it like that, I don't mind. Okay, so the up force equals the down force plus 3G plus 2G. So I have R equals 25G, firstly. Okay. Now, let's see. Louise,
Yeah.
this one here, clockwise or anti-clockwise if I use here? Clockwise or anti-clockwise? What are you saying?
Here is cross.
Here and the up.
Okay, this one is anti.
Anti-clockwise. And then Saeed, what about this? This one here. This one is clockwise, yeah. So I only have 1 anti-clockwise, but I have 3 clockwises. So I get to say x or equals, yeah? Oh, sorry, right, go down? Or actually, maybe I can just put this down. X or equals 3 multiply 5G, so that's 15G, plus 5 multiply 3g, so that's 15g, plus 6 multiplied 2g, 12g. So you get XOR equals 42g. Now that's great because, yeah, I can put this in here. So I get X25g equals 42g, so therefore X equals 42 over 25, what's that please?
1.68
meters. Okay. So that's number 3. That's okay. Is it gone by or is it stopped? Gone by. Ambulance? Fire truck? Fire. Okay.
Isn't multiply 25 by G?
You can multiply it if you want by G. 9.8, yeah? Yeah, you can. You can. That's fine. I didn't because I know that I can cancel my G at the end, but no problem. If you want to multiply by 9.8, then you should do that. Yeah. You'll get the same answer. So don't worry about it. In the exam, it doesn't matter if you multiply by 9.81 at the start or if you do it at the end. It's not important. It's okay. You can do it at the start. Well, you still write in the G, but you can leave it as G until the end when you get the answer. You know what I mean? Like here, what I did was I did this. Yeah? So I know that this G and this one cancel. But if you want, you can put in the 9.81. I mean, it doesn't matter because it will still cancel. So it's okay. Alright, did you write that down, Louise? You needed this one, didn't you? Yeah, and you wanted this one too. Yes, I think it should be recording. Yes, it is, yeah. Okay. So, we happy with this now, or do we need, let's see, how are we doing? Yeah, do we need anything else from this one? I mean, they're all pretty similar, you know, 1, 2, 3, 4. They all look the same to me. I think the difficult one is the next one. Louise, were you able to do number 3 here? In this one?
Yes.
Huh? No, because you have them here, but not here. And what about Young? Were you able to do this? Could you do this one?
No.
You couldn't. Could you do this one? First one? Second one? Maybe?
I do the second one as the one I finished.
You sure you didn't do the second one?
Okay, because you have the example in the...
I have the example, yeah. How did you do, Young, in this one? Did you do... Yeah, this one. Okay, you need to try this then, yeah. And you got these? Yeah, okay. So, I'm going to do number 3 and number 4. And if there's time at the end, I can go look at the other ones then, okay? Well, I'll first do 3 and 4 then. So I'm going to do 3 now. Right, so in 3 you have this here. Here is 56G. Here is 21.5G. Here is an OR. And then here is a P. And you're told that this angle here is 30. Which means that this piece is P cos 30. And then this piece here, P sine 30. Okay, now do we have distances? Let's see. It's 4 meters long, So that means here to here in the middle is 2. This here to here is 1, and then the full length is 4. So here all the way to here, that's 4 meters. Okay? Right, so let's see what we can make. I have or equals 56G plus 21.5G plus P, hang on, I might be missing something here, P cos 30. Yeah, sorry, there's something else here which they don't have on the picture. You see here, it's balanced on a table, and there's actually some friction on the table, which I'll just call it as F. Now, the reason I knew something was going wrong, maybe someone could tell me, why did I feel like I was missing something in my picture, in my diagram?
Different forces, right, forces left.
Yeah, if you look, what's the force going to the right? P sine 30, right? So there must be some force going to the left, because if there wasn't, the thing would be moving to the right. So there is some friction. But they don't say that until the second part. So sometimes in the exam it's good to read the whole question before you start the first part. Okay? Anyway, so I have or equals that, that, and that, and then I have F equals that. Now here, how many things do I not know? I don't know P and or. I need another equation, but I'll just use turning force, so it's fine. And I'll take, for a change, let's take this as the turning point for a change. So, Young, this here, clockwise or anti-clockwise, this one, and I use this point. Anti-clockwise. So I have 56G. Okay, and then Ugo here, clockwise. So I should put that on the other side. Yeah. And what's the distance I should use? 1. Yeah. Okay. So that's that one done, and that one's fine, that one's fine. Okay, now here, Louise, this force here, clockwise or anti-clockwise? Oh, I tricked you. Nothing. Thank you, Saeed. Nothing. Oh no, this one here, Saeed, would you know this one?
Clockwise?
Clockwise, yeah. Sorry, I forgot which side I'm calling. This I'm calling... This one's anti and this one's clockwise. Okay, so plus, and the distance would be 3 meters. 3p cos 30. Now this is really, really good because I can get the p now. I have 56g minus 21.5g divided by 3 cos 30. That equals the p. Okay, what's that on the calculator? What is it? 130. Is that what you got? Okay. Anyone get 130? No. Oh, so you did it, but you got the wrong answer?
Well,
What was your very silly mistake? Share it with us.
each of everything, divided everything by 6g over everything.
That's 6g over 21.5g.
Oh, that is a silly mistake, yes.
What happens, because the way Kuhn and I did it was we took it from the end.
Yeah, it should still get the same answer. But the thing is, the advantage of using the point here, the advantage of using this point is I know my equation will be simpler, that it will only have p in it, because the or here will disappear from the equation, because it's gone through the point. But I think what happened for you, Ugo, is, and maybe Hu and Ibrahim as well, that maybe you had two equations? Or
Well, then we just find out what R was equal to, and we stuck it back into the...
oh, okay, you got or first.
Yeah.
Yeah.
I know, but I made a mistake anyway, so my answer would be different, because I did P cos 30G instead of P cos 30. So...
Oh, you added a G in?
Got a G in, so...
Yeah.
Maybe
Your answer would be off, yeah.
So what did you say your answer was?
130.
Yeah, like basically if I multiply G back in, I get 130 as an answer.
Oh, of course, I didn't have the answers at the back for this one.
Yeah, that was the main...
Yeah, sorry, yeah. So 130 newtons is the first answer. Yeah. Can you go next page? I forgot.
Yeah.
The answers are missing. So this answer here, for 130. Yeah. Guys, I forgot to put the answers at the back for this one, so can you write it in? Or Louise, with a pen, I'll write it in. So this first one here is 130. I'll borrow this on it. Okay, we can go on to the next part? Yeah? Okay. Now the second part, I already answered. Maybe Louise, maybe you can explain it to me. Why do I need friction here? Why must there be friction force here? What's the reason? Could you tell me? You can try. Yeah, why do I need friction force to the left? Yeah, go on, yeah? Yeah, go on, don't be shy. We're all friends. What's the reason you think?
You need to balance.
Yes, you need to balance what? What are you balancing?
Balance for the...
Yeah, balance what, Syed? Yeah, I'm not pushing. That's it, yeah. So the P sine 30 is going to the right, so you need to balance it to the left. Yeah. So you said pushing, but it's actually pulling, but I know what you mean, okay? So that's the answer for the second part, is we need the friction force to balance the P sine 30. Okay? So can you write this down?
Yeah.
Here, I'll let you write this down. So you need the friction force to balance the P sine 30. Is that what you wrote? Or just calculations, yeah? Who? Did you get 130?
Yeah.
Okay.
It made sense with the G.
With the G?
Yeah, but like it. The answer is correct. It's multiplied by G at the end, you get like 130.
Oh yeah, it's for P, so you just worked out what PG is, so you have to multiply it by... You got 13?
I got 13, yeah.
Yeah.
Multiplied by G.
Ugo, can you just read out the third part to me? What's it asking for?
Give a sketch diagram to show the horizontal and vertical forces right down it says calculate the magnitude and direction of the solar force that Philip exerts in the beam.
Interesting, okay. Now, I find, sorry, let me be a bit clearer. I notice sometimes in the exam that later in the question they ask you to draw it. So, Ugo, you just said in part 3 they ask you to draw the force diagram. Now, I find this really, really strange because the first thing you should always do is to draw it. So, I don't know why they do this. So, in fact, I have the answer for part 3 at the start.
Just give 3 marks.
Yeah, but I don't know why they don't ask you to do it at the start. It's odd. But anyway, like I said again, read the whole question first, okay? Now, the next part, is this still part 3?
Yeah.
The 4, yeah. What they want you to do next is to calculate the total force here. So I'll just draw this again down here. If you look, there are, can you read it carefully, what they're asking for, the pivot part?
Calculate the magnitude and direction of the total force that the pivot exerts in the beam.
Okay, the pivot exerts on the beam. So the pivot is doing 2 things. The pivot is pushing up with ore and pushing left with friction. Yeah, F. Now we already know this. Oh no, we don't know it. We know the P. But if I put this answer in here, I can get the F. So what's 130 multiplied sine 30?
65.50.
65.
That's friction, that's for friction.
Oh, sorry. Yeah, give me this one first.
R is 89, G friction.
By using this, you get all the. Oh, sorry, you're right. Sorry, you go. Yeah, sorry. F. What I'm doing now is the F. And what did you say that was?
65.15.
65.15 newtons. Okay. Now, how can we get the ore? Oh, yeah. So we can just put the P in here, and we can get the ore as well by using this. So what do we get for the ore then? You got 72 for ore. 872. Okay. So we've got 872 newtons. Yeah, so look, I'll just draw this again on a triangle. What's the force going up? 872 newtons. And the force going left is 65.15 newtons. They want the magnitude. In the first week of physics we did magnitude. How do you find the magnitude here? What do we use to get this? Yeah, what's it called? What theorem?
Triangle.
That's right, Pythagoras, yes, go D. So here is square root 872 squared plus 65.15 squared. What's that?
875.5.
So 876 newtons.
Yeah.
Okay? And now they want the angle. And who remembers how to get the angle? It's tan inverse 872 over 65.15. Okay, what's that, please? So those are 2 answers for part 3.
What's the, the beam shows the west and north.
What's this in the angle?
Yeah.
Compass? Yeah, if you want, you would say this is west 85.7 degrees north. Or I think another way of saying it, Ugo, is 85.7 degrees north of west.
So it's what the answer literally.
Oh no, this is just that extra piece is for Ugo.
Okay.
Forget about that. Alright. He was just asking me something. They're the 2 answers for part 3. Yeah. Is that all of that question?
Yeah.
Yeah. Okay, number 4 was difficult, yeah? Yeah. Give me the copy, Ugo, of the questions there.
Examination.
Oh yes. I'm sorry to tell you this. Oh yes, it is. Yes. No. These 4 questions, I took this from 4 different exams. So they're definitely exam questions. I didn't take them from a book. Some questions I take from a book, some I take from an exam. Depends on the topic. Right, 4 now. This one does look difficult. Let's have a look at it. The diagram shows a sign resting on a footpath outside a restaurant, held vertical by 2 horizontal legs attached rigidly to the sign. The sign is 2 meters high and 1 meter wide, and the whole assembly has a massive 8.2 kilograms. A wind blows perpendicularly against the sign at a speed of 4, and so on. So the first part, it says, what's the mass of the air hitting the sign per second? Okay, so I'll draw what they're talking about. Here you have your sign, and here you have some air that hits it. Okay, so they want to know in 1 second how much air hits the sign. Okay, so what I'll do is I'll draw it again. Well, sorry, I'll redraw it. How fast is the air going? It's going 4 meters per second. Yes? So yes, in 1 second, that means 4 meters is travelled by the air. So what I'll do is I'll draw 4 meters out here. Sorry, this is ugly. Let me draw this nicely. Blue for air. Okay, so here is the sign, the face of the sign. Now this sign is 1 meter here, 2 meters here, and then what's happening in 1 second, all the air in front of it for a distance of 4 meters hits the front of the sign. So this is really where you have to use your imagination. You know, if I say the air is moving 4 meters per second, it means in 1 second the air that was here is now here, if it's 4 meters. So all that air, you see all that air in that 4 meter distance, that will hit the sign in 1 second. Okay, so do we understand what I'm saying with this? Yeah? Okay? Next. What's the volume of this shape of air, this box of air? Yeah, it's 4 multiplied 2 multiplied 1, so that is 8 meters cubed. In our first lesson we had this formula. Density equals, mass over volume. Do you remember that from the first lesson? Density equals mass over volume? Yeah. So that means mass equals density multiplied volume. And they give you the density. They tell you it's 1.4. So we multiply this by 8, and then what do we get? 11.2. Right. Is that I mean, it's okay. I know it's difficult, but I am recording it, so you can watch it again too. Now the second part. This air here has velocity of 4 meters per second, but when it hits the sign, it has velocity afterwards of 0, because it hits the sign and it stops. You know, the air goes flat. So they want to know the change in momentum. So that's the momentum after minus, and this is for the air, minus the momentum beforehand, which is 4 multiply 11.2. Because remember, momentum is mass multiplied velocity. So this here is 44.8. And the minus means it lost it. So it's a loss of 44.8 kilogram meters per second. Wait, that's not the answer.
Is,
I have 4 meters here as my answer.
because you, no,
Oh, sorry, the question said, show that it's 44.8, yeah, so I got 44.8. Well, they want the force,
Yes.
so, yeah, if you, just one more step. Do you remember from Newton's second law, force is the change in momentum over the small time. So that is 44.8 over, what's the time here?
Well,
Oh, that's the speed. The time?
what?
1. So that is 44.8 newtons then. So I don't know why I have 4 here.
I think that's the answer for the next question.
The next part?
Yeah.
Ah, right, okay. So I just have my 1, 2, 3, 4 labelled wrong. Right, that's part 2.
This is the last question, that's 200.
Ah, well, there you go, problem solved, yeah. Assume this force acts horizontally at the centre of the sign. Calculate the minimum length of the legs marked X on the diagram for the sign not to be turned by the wind. Interesting. So I'll draw this again. But this time I'm going to draw it from the side first. So here you have your sign, and then here you have your legs. And then here you have the air. And what did we say the force is from the air? 44.8 newtons. Okay? Now they want to find this distance here for the X, for the legs, because they don't want this to turn. Oh, and we must also include our force, the weight. What's the mass of this here? It's 8.2. So there's a downward one here of 8.2 G.
I don't want to X for the whole thing.
Is X the whole thing, or I think, now I don't know, it looks like from the diagram I have here, X is the half the length of the leg.
Yeah, but I thought the question asked when it is X, that's when it's at the close.
Calculate X on the diagram so that it doesn't move, that it doesn't turn. Now this one is quite tricky, you have to think about this for a moment. They want to know how big this leg should be so that it doesn't blow over in the wind. So you imagine, if this leg was really, really short, it would easily fall, yeah? And if the leg was really, really long, it'd be very difficult to knock it over, yeah. Now, there is a force going right, there's a force going down, of course there's a force going up from the ground, and there should be a friction force going to the left as well, otherwise it will be sliding along the ground. So I'll just call this here F, and I'll just get rid of the F here. So I'll just put this in red. 44.8, that's an OR, that's an 8.2 G, and then that's the friction force here. Something's gone wrong here for me. No, maybe not. Let me think. I'm going to draw this again. Okay. So if you have this drawn, that's fine, but what I'm about to draw, don't draw it just yet. Okay. So I'm trying to imagine that if the wind, so ugly. If the wind was blowing this what would happen? This would lift a little bit off the ground, wouldn't it? Like, I don't, if we picture it here, okay, and the wind's blowing this, you know, it would lift up at this end. But if I have, if I have a leg here, and I put it on it, and the wind's blowing it, it'd be going up from this point here, wouldn't it? I mean, if I make this really long, like if we got a smaller one, like here, this one would be easier to knock over than this one here. And the reason for that is because we picture, it's like you have this here, and you're trying to turn it from this point here. So there won't be any contact between the ground and the leg here. It'll all be here. So what I'm trying to say is, I think in my last picture, I drew the oar in the middle. I think this was wrong with me. I should have put the oar here. That's why the X is important. Because in this picture it looks like the X is not important. So I think I should put the oar here instead of in the middle. Okay, so I'm going to move that to the end. Now I know this one is a very difficult question, I know. So if I put it here instead, okay. Right, what point should we take as the turning point? What would be a good point to take? I'm thinking maybe here. What do you think? It's fine, isn't it? Yeah, I'll take it there. Okay. So firstly, the force going up is or, and that should equal 8.2 G, the force going down. What's the force going to the left? Saeed, and what's the force going to the left? What force is that? Going left? Which one's going left? It's this one, sorry, maybe my picture's not clear. This one here. This is the F going to the left. And then, Ugo, which is the force going to the right? 44.8. It's the 44.8 is the one going to the right. So I have here 44.8. Okay? Now I do clockwise and anti-clockwise. So here, Louise, if I take this as my point, turning point, is this clockwise or anti-clockwise? So I have clockwise and I have anti-clockwise.
Clockwise?
It is clockwise, yeah. So it's X times 8.2 G. And then, Ugo, what about this one here? This one here? Yeah.
Clockwise.
It's clockwise as well. But what's the distance to use? Well, you don't have the picture. This is the distance here, which is going to be 1 meter. Because they tell us the height is 2 meters, so this distance here is 1 meter. And it's 44.8, isn't it? Yeah. Okay. And then, let's see, who? This or here, clockwise or anti-clockwise? Anti-clockwise. And what's the distance? 2x, isn't it? Yeah. 2x multiply or. Do you know what or is? Yeah. So you can have 8.2 gx plus 44.8 equals 2x multiply 8.2 g. Okay. Saeed, can you just type 8.2 g on the calculator, please? Tell me what number that is. Yeah, 8.2 g. And can you multiply it by 2? 18.44, was it? 160. Point. Wait, hang on, sorry. Let's just Saeed firstly. What did you get here? 1. Yeah.
0.
Yeah.
Going to 80.
88 newtons. And before it was 80.44 newtons. Yeah, for this piece here. Okay, good. Thank you. Okay, and then here is x plus 44.8 equals that. Okay, so now I have, there's an x here. So now, Saeed, as well, if you could do 160.88 minus 80.44, that's 80.44, isn't it?
Yeah.
Yeah, 80.44x, and here is 44.8. Okay, so last thing to do is divide,
Okay.
and what do we get for x?
That's what it was. About 0.56.
56, yeah.
That's because I got that because I didn't see the answer. The answer is 4, wasn't it?
Yeah, it was off by 1, yeah. Yeah.
I don't know, just because I did it.
Did you do it like this? No, you did it a different way.
Yeah, a bit of a different way. Like instead of using F, I just used R.
Oh, but this is the thing, I didn't know at the start of the question if I would need the F. I
just did that the force is going, like, as an actual force going diagonally, and I used R cos and R sine, and I just didn't use
for the reaction, yeah.
Eventually they can't.
Did I not do that?
I just used F.
I used or and F,
Yeah.
and you did or and an angle. Yeah, okay. It would be the same thing in the end.
Yeah, so it was the same thing.
Yes, yeah. I don't know actually what they had in the market scheme, but they like using angles, so I was probably doing the angles. Okay, there's still one part left to this. On a day when there is no wind, a child pushes against the side in a direction perpendicular to AB. Perpendicular to AB? What?
I think A isn't the length of the sign.
Yeah, and B is perpendicular to... Is AB supposed to be...
I think on the sign, isn't it? The distance between the two sticks.
That's what it looks like, yeah. A child pushes perpendicular to AB. Okay, fine. If the center of gravity is 61 above the bottom of the sign, give a sketch of the diagram of the sign when it's just about on the point of falling over and calculate the angle that the legs will make with the ground in this position. Whew, okay, that one's also tricky. Alright, the last part here for this one. Can I go down? Yes? Okay. So here, on a day when there's no wind blowing, a child pushes against the sign. If the center of gravity, so they're saying the distance here is 0.65 above the bottom of the sign. Give a sketch of the diagram of the sign when it's just on the point of falling over and calculate the angle the legs will make with the ground in this position. Now, yes, okay. I'll draw this for you in slow motion. Okay, so here's the sign here, and here's the center of gravity, and here's the point here on the ground, and the child pushes, and this is going to turn. Now, tell me this. Like here, I'll push this, but then at some point, when I push it enough, then it will fall. So what's special about that point when it's about to fall? So all the way, but then at one point it falls. Yeah, what's special about that point? Do we know?
Forces advance.
No. Does anyone know? So it's the reason, if you're falling, if you are too far, you'll fall. Like with the sign. If I push it a little bit, it'll fall. But when will it be too far and then it completely falls? Well, it all has to do with the center of gravity. Okay, do you remember we were talking about center of gravity? So center of gravity is in the middle. Isn't it? You see here? See that turning point? I'll go down a bit. See here? This is where it turns on the ground. Okay? As soon as this point is above this point, that's when it's balanced. And then when it goes past it, that's when it'll fall down. Now why is that? Well, if you look here, there's a force here. And then as this moves up, so like if it was here, the force is still going down. Let me draw that again. I'll do it in red. So when the sign is, if the sign is here, in this position here, when the force is straight above the turning point, it's balanced. But then as soon as the sign, its center of gravity goes past this point, then that's when it will fall. But if you have the force right above the turning point, it's balanced. And if you push it, then it will fall. Okay? So if we just watch, I'll show you something here actually. Oh, I don't have it saved, I don't think. Oh, rats. I'll have to find the video again. Anyway, so I had a video of somebody with a can of Coke, and what they did was they balanced it. Yeah. And you can do this when the center of gravity is directly above the turning point. But when it goes past it, then it falls, okay? So they want to know, when is it balanced?
If we can find at this point, I can balance the
yes.
angle can this.
Oh yes, you can.
Okay.
What if we need something with a flat base. Yeah, go on, give me. I'll try. You know, I see it's not going to work if it's shaking.
How do you know? How do you know the point?
I'll try. You'll do that in the SAT. How to find this point.
Yes.
Yeah, you'll do it in the SAT. No. But you get the idea. You can balance it if the force is directly above the turning point. Okay? So they want to find the angle here. Okay. So if I draw, again, it's like this. Yeah. Here's the turning point. Here is the center of gravity. Here's the force going straight down. Here is 90. And they would like this angle. Okay? Now they tell us that this distance here is 0.65. And you know this distance here is x. And we found x. What was our x? 0.56. Yeah? Wasn't that what we got for x?
Yeah, it was.
Yeah. So, Ibrahim, can you give me this angle here? It's tan inverse 0.65 over 0.56. What's that? $49.2? Maybe not 0.4? Okay, 0.2. Yeah. Now, this angle here is going to be 90 minus that for this one here. So what's that, please? 40.75. Close enough. The answer I have here is 40.6. I think maybe for the previous answer I should have taken one more decimal point. Anyway, about 41 degrees. Is this yours? Susan, is this yours? Yeah. The which 40? 90 minus 49.2 is how I got the 40.75. Yeah. Because, Saeed, this angle here, that's the 49.2, but I want that angle, the other half.
What about the 0.65?
Given in the question. It's in the question.
Okay.
That's so you are. Yeah, it's, they say it's, part 4, the 65 centimeters. Yeah. What does COG stand for? COG?
Center of gravity.
Very good. Center of gravity. It's the point where you can balance it, really. It's the balancing point, I suppose. It's another way of saying it. You know? And you will learn how to find it in ESAP. I gave the lesson to Stephen B. He'll do it with you about finding this point. Some people maybe know how to find it. The center of gravity, yeah. But Saeed has it there. Yeah?
Well, and then I was asking about the weight one.
Yeah?
You've used the experiments.
Oh yeah, well, there's many ways to do it. Weights, plumb lines, all this, hanging it, yeah, all these different things. Okay, we'll finish that off.